In this next video, we're going to practice solving several radical or rational exponent equations. Let's begin. First one, top left corner, 7x to the 3/5 power equals 56. Well, the idea here is I need to undo all the stuff that happens to x in reverse order. So x to the 3/5 times 7. To solve for x, I need to do those things in reverse order and use the inverse. So instead of multiplying by 7, let's do the inverse and divide by 7. So I get x to the 3/5 is now equal to 8. Then to undo the raising of something to the 3/5 power, I want to have x to the first power when I'm all done. So what I'll do is I would like to raise this to the reciprocal. So if it had been raised to 5/3, I'm going to raise it, or excuse me, had been raised to 3/5, I'm going to raise it to the 5/3. Because when I raise a power to another power, I multiply. And 3/5 times 5/3 would equal 1. 3 times 5 is 15, 5 times 3 is 15, and 15 divided by 15 is 1. So x to the first. Now if I do something on the left side, I should do the same to the right side of the equation. So I will also take 8 to the 5/3 power. Now that's something you could type into your calculator, or you could think about this. This means the cube root of 8, and the cube root of 8 happens to be 2, and then take that to the 5th power. Well, 2 to the 5th power is 32. So x equals 32 would be the answer that I come up with. Now I would make sure to plug this in and check it out. Let's see here. 32 to the 3/5. That means the 5th root of 32, which is 2. 2 cubed is 8. 8 times 7 is 56. We have a correct answer. Good deal. Moving on to the next one over on the right. X minus 4 to the 2/3 minus 9. Well, I need to get the power by itself before I raise it to any other power or take a root or anything like that. So I'm going to add 9 first. Adding 9 will give me x minus 4 to the 2/3 on one side, and 16 plus 9, which is 25 on the other side. Then raise it to a power. Well, again, we'll raise it to a reciprocal power. So instead of 2/3, we'll raise it to the 3/2 power. Same thing over here on the right side, 3/2 power. The left side will now just be the inside, which happened to be x minus 4. Because I've undone the exponent. It's now being raised to the first power. The right side, 25 to the 3/2 power. Again, a rational exponent. The bottom number means take this root. So let's take the square root of 25. Well, that's 5. And then cube it. 5 cubed is 125. And again, you can always check your calculator on that one if you're not sure. Last step, let's add 4 to get the x by itself. So when all is said and done, x is equal to 129. Plug it in, check it out. 129 minus 4 is 125. Raise the 2/3 power. Well, it's going to be cube root, which is 5. Squared is 25. 25 minus 9 is indeed 16. This is the correct answer. Let's move on to some things that might be slightly more difficult. So when I have a square root, the idea is to get the square root by itself and then square both sides, cube both sides, whatever it might be. So in this case, I have the square root of x minus 6. It's by itself. This equation is ready to be squared. The tricky part is this. There's 2 terms on the right side, which means you need to square that entire expression. Put parentheses around it. Now, we'll talk about this in a second. First of all, the square root of x minus 6 now squared will equal just the inside, which is x minus 6. But the right side, here's where things are a little tricky. X minus 8 in parentheses squared means, remember, that I need to take x minus 8 times x minus 8. I am foiling that binomial. Now you could use our pattern that we remember that Mr. LeQuay taught me a long, long time ago. In order to square a binomial, you square the first term. Okay, take that and square it, and you get x squared. Multiply the 2 together, so take these 2 terms together, you get negative 8x. Double it, which would turn into negative 16x then. And then square the second term. Well, that squared is going to be 64. Same thing would be if I foiled these 2. This is what I come up with. So now you'll notice that the equation I have is x squared, and then some other things. But the fact that there's an x squared means that this is now a quadratic equation. We could use the quadratic formula or factoring or any other method we've already learned to solve this. So normally with quadratic equations, the idea we needed to use is we needed to set it equal to 0. So I'm going to clear out one side of the equation by subtracting an x and adding a 6. which would leave me with 0 on the left side, and on the right side I would now have x squared minus 17x plus 70. Now, of course, because it's a quadratic equation, you could use the quadratic formula, especially those of you who love to type that in on your calculator. It will work. However, I'm going to factor this one instead, just because I like to factor. And I notice that the first term is going to be x in each of these factors. The second term in each needs to be factors of 70 that add up to negative 17. Well, how about negative 7 and negative 10? That's not so hard, is it? Now, if those two factors multiply together equals 0, then either part can equal 0. So my answers in this case would be x equals 7 and x equals 10. You can plug it back in. Now, I say you can plug it back in, but we really need to because of this little thing way up in the top corner which says check for extraneous solutions. Sometimes, because of the way that square roots and cube roots work, especially square roots, sometimes we get answers algebraically that should make sense, but when we plug them back in, they don't actually work. So let's plug them in each at a time. Let's plug in 10 first. Take 10. 10 minus 6 is 4, and the square root of 4 is 2. And on the right side, 10 minus 8 is also 2. So 2 does equal 2. That's true. What if I plug in 7? So this one works. A little circle. 7 minus 6 is 1. The square root of 1 is 1. 7 minus 8, however, is negative 1. 1 does not equal negative 1. So this one would be what I would call an extraneous solution. It doesn't actually work. Even though we did everything right algebraically, for whatever reason, that one is an extraneous solution. When I say extraneous, see the word extra at the beginning. It doesn't actually work. You don't necessarily have to list them. I like you to list them because then I know that you found both algebraically and then checked them out. Technically, all you have to do is list the one that is a solution, which would happen to be 10 in this case.